Hello, this is Dr. Mears. Today we're going to be calculating the Pearson's product moment correlation coefficient by hand. If you do end up using a scatter plot for your internal assessment, your IA, you're going to need a further process, and this can be considered a further process. So let's get going. Here's our example. The table shows the size of a television screen and the cost of the television. So we have size in inches, 32, 37, 40, 46, so on and so forth. And then we have the cost in dollars, 450, 550, so on and so forth. Number one, calculate the Pearson's product moment correlation coefficient, known as R, by hand to determine the strength of the linear relationship. Use your GDC, graphical display calculator, to verify your calculations were correct. So we actually looked at this scatter plot, and you had to run a form, outliers, direction, strength, and context on this. So basically you had to interpret it. And what you did see is a moderately strong linear relationship that was positive. So as the size increased, so did the cost of the television. You then had to find the mean point, and you would plot, you would plot the mean point, and then you would draw your line of best fit. Well, what we're going to be doing today is we're going to be determining how strong this is, because we said moderately strong, but what is moderately strong? We're going to be calculating a number to determine that strength. So here we go, and we're doing it by hand. In order to do this by hand, you had to get this green sheet. It has two sides to it. It is the Pearson's product moment correlation coefficient. It's your further process. Here's your formula. This is your formula right here. R equals standard deviation of x and y divided by the standard deviation of x times the standard deviation of y. The standard deviation measures the typical distance of the values from its mean, and that's why we were finding the mean point on our calculator. So once you find that middle point or that mean point, our regression line is going to pass through it. So we want to know how far each of these points are from that mean point. And that's why we're using standard deviation to calculate the regression. So this is R. The line of best fit always passes through the mean point, x bar, y point, which is why we need to know how far it is. Another little cute note over here, this is capital sigma. It's a Greek letter. It means you add them all up. So we're going to need to know that. So in order to run this formula, to put our numbers in, we need to find a couple things. So the first thing that we need to find is the standard deviation of x and y. Here's the formula for that. The second thing we need to find is the standard deviation of x. Here's that formula. And the third thing that we need to find is the standard deviation of y. There's that formula. Very similar. This deals with the x points. This deals with the y points. This one deals with the x and y. The easiest possible way I thought about teaching you this is using tables. So if you flip to the, if you flip to the back of the sheet, you will see three tables, 1, 2, and 3. And so this is going to keep your work nice and organized. There's a couple pieces of data that we need. We need the n, which is the total number of observations, the mean of x, and the mean of y. If you want to write that in, that's fine. Total observations, that's n. This is your mean of x, and this is your mean of y. And you can find that through your calculator if you remember the two variable statistics. So once you turn your calculator on, you go to stat and you enter, and you see that I have a lot of information. The only two lists I need is L1 and L2. So I have L1 and L2. We go to stat, and we want to calculate. Now, because we have two variables, an x and a y, we're going to be going to two variable statistics. That's that. We need to tell it what lists we need. I need L1, comma, which is and. I need L2. When you do that, you're going to see you find x bar. X bar is 45. I'm going to round to three significant figures, so 45.6. If you scroll down, you see n. N is 7. And a little bit more, y bar, which is the mean of y, is 1,100. So why don't we write those three values in here? We're going to write 7, 45.6, and 1100. And now on our charts, we can begin to fill some things in. This is going to deal with our x. So let's first figure out everything we need with x. This x right here, this is really just your list 1. So any numbers that you put in your list 1 or your size in inches, so that's what this was the size, you're going to write here. So you're going to write in your 32, 37, 40, 46, 50, 55, and 59. It's okay that you didn't use this bottom box because I just did extras. This X bar here, you're going to fill in your mean, 45.6. So it's going to be the same number all the way down. Now, instead of you sitting watching me here, what I have done is started to complete these tables. Okay, so this is what I have right now. I have my X, which was my size, my television size, and then I have the mean of X, which was 45.6. The next column, what you're going to do is you're going to subtract your X, which is 32, minus your mean, 45.6. Subtract those two, write it down. You're going to subtract 37 minus its mean, 40 minus its mean, all the way down. There is a nice easy way to do this on the calculator. However, you have to keep things accurate, and I can show you that in class, but you have to ask me, I will show. Okay. After you subtracted all of these, what we need to do next is we need to square the values. The reason why we're squaring the values is because we want to not have this negative. So we square the negative 13.6 squared, we get this number, negative 8.6 squared, this number, so on and so forth down the line. On your calculator, that squared button, if I was going to do this, I would put negative 13.6, I'd put it in parentheses and then square it. Remember, when you are doing this in the calculator, please use the parentheses because you do want to square that negative number, and I got 184.96. So do that all the way through. And now this is where you have to make sure you're paying attention to your decimals. You don't want to slip up, and you want to double and triple check to make sure. Okay. Once you have all of these numbers, you are ready to take what's called the sum. So I need you to take each one of these numbers and add them all together. So basically you're finding a total. So add up each one of these numbers and you should get 577.72. Yay, we got one. Okay. Next, you're going to do the same for the y. The y value is going to be your cost. So this was your L2, which was your cost. And you're just going to write those numbers down. Then we found that mean. You're going to write down the mean. Remember, it's going to be the same. Because what we're going to be doing is the same exact thing. We're just going to be subtracting the value minus its mean. So 450 minus 1,100 is negative 650. You're going to be doing that all the way through for each and every one. Now again, this could get tedious. We only have 7 here. For your IA, you're going to have 50 plus pieces of data. So what we're going to do is we will explore Google Sheets, we will explore Excel, so that you can make your lives a little bit easier. You don't have to go and do this 50 times. There are certain things and programs that you can use, so we will be doing that. However, I do want you to know how to do this by hand, because you have to do it for your IA. So after you subtracted each one of those, you're going to do the same thing. We're going to square it. So negative 650 squared equals 422,500. Do that for each one of these, square them, and here is what we get. Now, you also need to get the sum of that. So you need to take all of these numbers, add them up, and you should get this sum here, 2,205,000. Okay, on to our next one. Our next one is just one little column. What you need to do is you need to multiply the value of x minus x bar and y minus y bar. So the two columns that we're going to be looking at is this one here, x minus x bar, and this one here, y minus y bar. So you're going to take negative 13.6 and multiply it by negative 650. That's going to give you 8,840. You're going to go all the way through, negative 8.6 times negative 550, that answer. 1, 2, that answer. And after you've multiplied those two columns, we need to add them up again. Hence, we need to get the summation of all of those added up. and you should get 34,850. Now I'm going to leave this right there. If you need to pause or rewind, this would be a great time because I rushed through it, especially because I had the numbers all done out. So if you want to check your numbers, if you want to go back and you need to finish adding up the numbers, please do so now. Okay, we are back. So here we have the summation of x minus its mean squared, the summation of y minus its mean squared, and the summation of x minus its mean times y minus its mean. These three numbers, what I want you to do is transfer these to the front of your paper because we're just going to put them in our formulas. So for s of xy, we need the summation of x minus x bar times y minus y bar. So on the back of your sheet, you're going to be taking 34,850. And what that looks like is this. 34,850 divided by n. Remember, n is our total number of observations, which is 7. So that number comes to be 4,978.6. Then you're going to look at your summation of your x values, 557.72, and you're going to substitute it into this formula. This is the square root. Please divide 577.72 by 7 first, and then take your square root. If you want to do it all in one function in the calculator, what I suggest you doing is first doing the square root and then parentheses 577.72 divided by 7 and end parentheses. Make sure that whole entire division is included underneath that square root, and you get 9.08, okay, which was this right here. And the last thing that you're going to do is you're going to look back and you're going to go to the summation of y minus y bar squared, which is this number right here. And you're going to substitute it into this last one right here. Again, make sure you divide and then take the square root. It's a very common mistake. So make sure you're putting parentheses around this if you're doing it in the calculator. And we get 561. We now have the three numbers needed, 1, 2, and 3. To put it into our formula. So we have our formula, some standard deviation of x and y is this. And that just came from here, so I replaced it, substituted it in. 9.08, this is times 561.2. These two numbers just came from this number and this number. We can now multiply and then divide this, or you can again put parentheses around this if you want to do it in one step. And we get our r to be 0.977. So on our sheet, r equals 0.977, and it wanted us to use our graphical display calculator to verify. So what we do is we make sure L1, yes, this is size, L2, that is cost, okay. We are going to calculate, and remember now this is for linear regression. Okay? And linear regression is going to help us get our correlation. We're also going to be using it to find the least squares regression line, which is the ultimate best fit line. But let's just verify R right now. So linear reg L1, comma, L2, so you told it which lists. You press enter, and you see R equals 0.9764. So that's this last number. So let's write that in. R equals 0.9764. Now, if I rounded this, it would be 0.976. So I am off by a teensy amount here, which is absolutely fine because I rounded so much with these numbers from the table that to be off by that thousandth place you're absolutely fine. So this is great. These would both round to 0.98. So we are on target. This is very good. So this could approximate 0.98. Because I would round up. This would approximate 0.98 because I would round this up. And that's great. So here you have it. This is a further process for your internal assessment, IA, if you are using a scatter plot and you have two quantitative variables. Hope this helped. Please ask questions. I am here, and I will talk to you later.